In this video, we're going to talk about power series. And let me give you an example of a power series. Here's one that starts from 0, goes to infinity. And a power series is basically an infinite series with the variable x in it. And x is raised to the n power. So this is a power series that is centered at 0. So c is equal to 0 for this one. And here's another power series, but this one is not centered at 0. In this case, the center is c. Now the first thing you need to be able to do is determine where it's centered at. So let me give you some examples. So for each of these examples, determine where each power series is centered at. Feel free to pause the video and try it. Now let's consider the first one on the upper left. Where is the power series centered at? So just by looking at it, you could see that it's centered at c equals 2. Now what about the second one on the bottom left? Another way you could find the answer is by setting the inside, in this case x plus 4, equal to 0 and solve for x. So at negative 4, this whole thing becomes 0. So it's centered at c equals negative 4. Now for this one, if you don't see a c value, if it's just x to the n, then it's centered at 0. You can write this as x minus 0 to the n, and that's the same as x to the n. Now what about the last example? If you don't see what it is immediately, set the inside part, 3x minus 2, equal to 0, and solve for x. And so you should get x is 2 over 3, and so it's centered at that value. Now the next thing that we need to be able to do is we need to determine the radius of convergence and the interval of convergence of a power series. And so you need to use the ratio test to do that. So let's say if you use a ratio test, you take the limit as n goes to infinity of u sub n plus 1 divided by u sub n. Now let's say if you get 0. What does this mean? There's 3 scenarios you need to be familiar with. This is the first one. So if the ratio test gives you 0, then it means that the series, it converges for all x values. It's always convergent. So the radius of convergence, that's r, that's equal to infinity. And the interval of convergence, it's from negative infinity to infinity. So what this means is that at any x value, the power series will converge. Now the second situation is after doing the ratio test, let's say you don't get 0. Let's say this time you get infinity instead of 0. So what does that mean? Now if you recall, in order for a series to converge, the ratio tests have to give you an answer that's less than 1. So if it's greater than 1 or if it's infinity, that means that it diverges for all x values except one particular x value. It will only converge when x is equal to c. At this point, you're going to get a limit with some expression of n times 0, so the whole limit is equal to 0. And because, according to the ratio test, is less than 1, it's going to converge for that point. But for everywhere else, for all other x values that is not equal to c, you're going to get infinity, and so the series will diverge for all other x values. But for this particular x value, where x is equal to c, it's going to converge. And because it only converges at one finite number, the radius of convergence is 0. And the interval of convergence is only one number. It's not a range of numbers. So the interval of convergence is just the x equals c value, or c itself. So let me separate the first situation from the second. Now let's move on to the third situation. So for the third scenario, if we use the ratio test, we're going to get an expression in terms of x. Typically, it's going to look something like this: 1 over r, absolute value, x minus c, which is less than 1. So it's going to vary, but c could be 4, c could be 0, so you may just see an absolute value of x. R could be anything, it could be 1/2, it could be 2, but usually in this format. And once you get to this point, you want to multiply both sides by r. And keep in mind, you want to set it less than 1, because you'll get this, but you need to introduce this inequality, because it only converges when the ratio test gives you a value less than 1. So this is something that you have to add, the less than 1 part. And then once you multiply both sides by r for this expression, you're going to get x minus c is less than r. So whatever number you see at this point, that is your radius of convergence. Now, because of space, I'm going to clear the board. So let's start with this. So this is where the series converges. Now, whenever the absolute value of x minus c is greater than r, then at that point, the series, it diverges. But since we're looking for the radius of convergence, we're not going to use this. So we're just going to be focusing on this expression. Now, to get rid of the absolute value symbol, we could say that x minus c is less than r, but greater than negative r. Now, if you add c to both sides, you'll get that x is between negative r plus c and r plus c. So the interval of convergence becomes this. It's negative r plus c, comma, r plus c. Now the last thing you need to do is check the endpoints, because even though you have parentheses here, sometimes you could have two brackets, two parentheses, a bracket and a parentheses, or parentheses and a bracket. So there's 4 possibilities here, and you have to check your endpoints, which I need to show you by example. But that's how you could find the interval of convergence. So now you know the 3 scenarios, so let's work on some practice problems. So let's say if we have the power series from 0 to infinity of x to the n over n factorial. Go ahead and determine the radius and the interval of convergence for this power series. So let's start with the ratio test. The limit as n goes to infinity of u sub n plus 1 divided by u sub n. And we need to see where it's less than 1, where the series converges. So u sub n plus 1, all you got to do is, in this expression, replace n with n plus 1. So it's x to the n plus 1 divided by n plus 1 factorial. And u sub n, that's just the original expression, x to the n over n factorial. So let's take the limit as n goes to infinity of u sub n plus 1. So that's this. And then divided by u sub n. So let's simplify the expression. X to the n plus 1, we could say that's x to the n times x to the first power. N plus 1 factorial is n plus 1 times n factorial. And then using the expression keep, change, flip, we're going to change division to multiplication, and we're going to flip the second fraction. So it's n factorial over x to the n. So we can cancel an n factorial, and we can also cancel x to the n. And so we're going to be left over with, I'm continuing from here. Just keep that in mind. I'm not saying this is equal to this here. So this is equal to the limit as n goes to infinity, and then we have absolute value 1 over n plus 1 times the absolute value of x. So basically separated x over n plus 1 into those two parts. Now, as n goes to infinity, what happens to 1 over n plus 1? That's going to go to 0. And 0 times x is 0. Now, what do we say will happen if we get a limit of 0? If the limit is equal to 0, which is always less than 1, then that means that the series, it converges for all x values. Regardless of what x is a fixed number, by the way. So if you choose x to be 2 or 8 or 25 or -4, all of those numbers, all of those fixed values multiplied by 0 is equal to 0. So for any x value that you choose, the series will converge. And so what does this mean? So for this situation, I believe we defined it to be, what was it, scenario number 1, I think? That was scenario number 1. And so when the limit equals 0, the radius of convergence is infinity. And the interval of convergence is negative infinity to infinity, because x could be anything, and the series will converge. X could be 1,000, it will still converge. And so this is the answer anytime you get a limit that's equal to 0. That's all you need to write. Now let's work on another example. This time we're going to have the series of n factorial times x to the n. Feel free to pause the video if you want to try it. So let's start with a ratio test. Now u to the n plus 1, that's going to be n plus 1 factorial times x to the n plus 1. And then we're going to divide it by u to the n, which is the original expression that we see here. So that's u to the n. So now let's simplify. So now we have the limit as n goes to infinity, and then n plus 1 factorial, that's n plus 1 times n factorial, and x to the n plus 1, that's x to the n times x to the first power, divided by these two. So now we can cancel x to the n, and we can cancel n factorial. And then I'm going to separate n plus 1 and x. So what I now have is that the limit as n goes to infinity of n plus 1, my absolute value doesn't need to be so big, and then times the absolute value of x. So you can move this to the front because it's not affected by n. So you can say that this is the absolute value of x times the limit as n goes to infinity of n plus 1. And n is always positive, so we really don't need the absolute value symbol there. But as n goes to infinity, what happens to n plus 1? N plus 1 also goes to infinity. Now, what does this mean? The absolute value of x times infinity. That means that the limit goes to infinity. And what do we know when the limit goes to infinity? This is the second scenario. That means that the radius of convergence is 0, and the interval of convergence is our c value. So what is c? So at what number is the function centered at? There's no x minus c to the n. It's x minus 0 to the n, which is x to the n. So we could say that it's centered at 0. So when x is 0, it's going to converge. Now let's understand why. So if x is 0, we're going to have the limit as n approaches infinity, n plus 1 times 0. N plus 1 times 0 is 0. So then the whole limit will equal 0 if x is 0. Now, if x is anything else but 0, let's say if x is a half, 1/2 times the limit as n goes to infinity of n plus 1, well, this is going to go to infinity, and if you multiply that by a half, then the whole thing is still going to be infinity. Half of infinity is infinity. So if x is any other value than 0, the limit will go to infinity, and so it's going to diverge. But when x is 0, then the limit goes to 0, and by the ratio test, that's less than 1, it converges. So anytime you do the ratio test, if you get infinity as your output, that means that it's only going to converge when x is equal to c. In this case, your c value is 0, so it converges when x is equal to 0, because the limit will go to 0. And so your answer for this situation is the radius of convergence will be 0, and your interval of convergence is your c value. It's when x is equal to c. So in this case, your interval of convergence is simply 0, because c is 0. Now let's try another similar but different example. So consider the series from 1 to infinity of n factorial times 2x minus 1 raised to the n factorial. So go ahead and determine the radius of convergence and the interval of convergence. So as always, we're going to start with the ratio test. So u to the n plus 1, that's going to be n plus 1 factorial times 2x minus 1 to the n plus 1 factorial divided by n factorial times 2x minus 1 to the n. So that's our u sub n. So this is u sub n plus 1, and this is the original u sub n expression that we see here. So go ahead and simplify it. So n plus 1 factorial, we can write that as n plus 1 times n factorial. And 2x minus 1 to the n plus 1, that's 2x minus 1 to the n times 2x minus 1 to the first power. And so we could cancel 2x minus 1 to the n and n factorial. And so now, what we have left over is the limit as n goes to infinity, and then we have n plus 1 and also 2x minus 1. So what happens when n goes to infinity? N plus 1 also goes to infinity. So we're going to have infinity times 2x minus 1. Now, where is the power series centered at? What is our c value? To find our c value, we need to set the inside equal to 0. So if you set 2x minus 1 equal to 0, x is 1/2. And so c is 1/2. Now let's think about what we have. If x is anything but 1/2, it's going to diverge. Let's say if x is 5. If we plug it in here, 2 times 5 minus 1, that's 9. 9 times infinity is infinity. So whenever x, let's say if x does not equal 1/2, infinity times whatever that value is going to be infinity. And so the series is going to diverge whenever x is anything but 1/2. But what happens when x is a half? Well, if you plug in 1/2 into this expression, we know we're going to get 0. 2 times a half is 1, minus 1 is 0. And so 0 times n plus 1 is 0. Thus the whole limit is going to go to 0, which means that the power series converges. So anytime you get infinity as a result, it's only going to converge when x is equal to c. That is where the power series is centered at. So for this problem, the radius of convergence is 0 because there's only one number where this series converges, one x value. So the interval of convergence is x equals c, which is just 1/2. So it's not always 0. It depends on where the power series is centered at. So this is the answer for this problem. So anytime you get infinity, the radius of convergence is 0, and the interval of convergence is where the power series is centered at. That's where x equals c. So you just put in your c value. Now let's work on another example problem. So let's say we have the power series from 0 to infinity of x raised to the 2n divided by 2n factorial. So go ahead and work on this problem. As always, let's start with a ratio test. So u sub n plus 1, that's going to be x to the 2 times n plus 1. So replace n with n plus 1, and then 2n factorial is going to become 2 times n plus 1 factorial. And then we're going to divide it by u sub n. So u sub n is just x to the 2n over 2n factorial. So right now what we have is x to the 2n plus 2. And on the bottom, we also have 2n plus 2 factorial. And then we're going to multiply by the reciprocal of the other fraction. So this is going to be 2n factorial over x to the 2n. Now, x to the 2n plus 2, we can separate that into x to the 2n times x squared. 2n plus 2 factorial. So let's say if you have 8 factorial, that's 8 times 7 times 6, and if you want to, you can stop at 5 factorial. So you have to keep subtracting 1 to get the next number. So if we start with the first number, 2n plus 2, to get to the next number, we need to take 2n plus 2 and subtract it by 1. So it's going to be 2n plus 1. And then if we subtract 2n plus 1 by 1, then we'll get 2n. We want to stop here because we can cancel it with the 2n factorial on top. So now we can cancel x to the 2n and 2n factorial. So what we now have is the limit as n goes to infinity, and then we have, since n is positive, I don't need an absolute value expression anymore. So this is going to be 2n plus 2 times 2n minus 1, and then times x squared, which is also always positive. So what happens to this expression when n becomes very large, when it goes to infinity? As n goes to infinity, that fraction goes to 0. And so it's going to be 0 times x squared, which is 0 for all x. So regardless of what x is, if it's 20, 1000, negative 50, if you multiply by 0, it's going to be 0. So this means that the series converges for all x values. So anytime you get an answer of 0 for the ratio test, that means that the radius of convergence is going to be infinity, and the interval of convergence is negative infinity to infinity. And so that's it for this problem. Now let's try another one. So consider the power series, the square root n times x minus 1 raised to the n. Go ahead and try that one. So once again, let's start with the ratio test as always. U to the n plus 1, that's going to be the square root of n plus 1 times x minus 1 raised to the n plus 1, divided by the original expression u sub n. So this is equal to the limit as n goes to infinity. Now both of these expressions, they're inside the square root, so I can write it as one expression, the square root of n plus 1 over n. Now x minus 1 to the n plus 1, that's going to be x minus 1 to the n power times x minus 1 to the first power. And so I can cancel these two. So what I have left over is the limit as n goes to infinity, square root n plus 1 over the square root of n, or just, I'm going to write it like this, and then times x minus 1. So what happens to n plus 1 over n when n goes to infinity? When n becomes very large, the 1 becomes insignificant. So you're going to get 1n over 1n, and so it's going to become 1. And the square root of 1 is 1. So we're going to have 1 times x minus 1. Now this is all still inside the absolute value expression. So we have the absolute value of x minus 1. And whenever you have, let's say, an answer in terms of x after the ratio test, set that answer less than 1, because we want to find out for what values of x it converges. So we can rewrite this expression. We can get rid of the absolute value expression by saying that x minus 1 is less than 1 but greater than negative 1. So now if we add 1 to all three sides, we can see that x is less than 1 plus 1, which is 2, but greater than negative 1 plus 1, which is 0. So therefore the interval of convergence is from 0 to 2, or at least it appears that way. We still need to check the endpoints, so we can adjust it shortly. Now what is the radius of convergence? If you recall, once you have this form, if there's no number in front of the absolute value, then whatever number you see here is the radius of convergence. In this case, it's 1. And you could see that we have x minus 1 or x minus c. So c is 1 for this example. It's centered at 1. And you can see it here too. That's x minus c. Now let's check the endpoints. So let's start with 0. We're going to see if it converges when x is equal to 0. So starting with the power series, replace x with 0. So we're going to have the square root of n times 0 minus 1 to the n power, or negative 1 to the n power. So does the series converge in this form? What would you say? Well, a simple way is to try the divergence test. The limit as n goes to infinity for the square root of n times negative 1 to the n power. As n goes to infinity, the square root of n, what's going to happen to that? That's going to be the square root of infinity, which is basically infinity. And then the only difference is it's going to alternate in sign. It's going to switch from negative 1 to 1, so our answer is going to be positive infinity, negative infinity, and so forth. It's always going to alternate. So we could say that the limit doesn't exist because it doesn't equal one value. Sometimes it will equal positive infinity, sometimes it will equal negative infinity. Now, if the limit doesn't exist, then we say that according to the divergence test, the limit diverges. So if it diverges, then it doesn't converge when x is equal to 0. So we're not going to include 0 as an endpoint. So we're going to leave it with parentheses. It doesn't include 0. We're not going to use brackets. If it converged, then we would use a bracket at that endpoint. So now let's test the other endpoint when x is 2. So we're going to have the square root of n times 2 minus 1 to the n power, which is 1 to the n. And 1 to the n is just 1, so this is what we have. Now, using the divergence test, this is going to go to infinity, so it still diverges. So 2 should not be included in the interval of convergence. Now let's plot the interval of convergence for this problem. So it starts at 0 and it goes to 2. Now it doesn't include 0 or 2, so we're going to have an open circle at those points. So anywhere in this region where x is between 0 and 2, the power series will converge. Now the power series is centered at 1, so this is the c value. And the radius of convergence is basically the distance from the center to the end of the interval. So this distance is r. And so we can see why r is 1, because between 0 and 1, that distance is approximately 1. So r is typically 1/2 of the length of the interval. So if it goes from 0 to 2, then if you take the difference between 0 and 2, which is 2, divided by 2, that's your radius of convergence. And so that's it for this problem. Hopefully this gives you a better understanding of it. Let's try this power series. Let's say it's x minus 3 to the n divided by n. So let's start with the ratio test. So u sub n plus 1, that's going to be x minus 3 raised to the n plus 1 divided by n plus 1. And then we're going to divide that by u sub n, which is x minus 3 to the n over n. So then we can write x minus 3 to the n plus 1 as x minus 3 to the n times x minus 3 to the first power. And n plus 1, that's not going to change. We're just going to leave that as n plus 1. Now we're going to change division to multiplication and then flip the second fraction. So we have this. The only thing we can cancel right now is x minus 3 to the n power. And so we're left with the limit as n goes to infinity of the absolute value, or we could just say 1 over n plus 1 times the absolute value of x minus 3. So as n goes to infinity, actually wait, I'm forgetting something. I can't forget this n, so let's put that on top. That would have been a very big mistake. So as n goes to infinity, what happens to n over n plus 1? The 1 is insignificant, so it becomes n over n, which becomes 1. So this is 1 times the absolute value of x minus 3. And so that's less than 1. And so we can say that x minus 3 is between 1 and negative 1. Now if we add 3 to both sides, then x is between 4 and 2. And the midpoint of 2 and 4 is 3, so we can see that it's centered at 3. So C is 3. Now, what is the radius of convergence? What is that equal to? Well, if you take the distance between the midpoint of the interval, which is 3, and one of the endpoints, the difference between 3 and 2 is 1. So the radius of convergence is 1. Or, once we had it in this form, the absolute value of x minus 3 is less than 1. We have it in the form of x minus c. The absolute value of that is less than r. So you can see at this point, r is 1. So now we need to check the endpoints. So let's start with 2. So when x is 2, will the power series converge or will it diverge? So 2 minus 3, that's negative 1. So we're going to have negative 1 to the n power over n. So notice that this is the alternating harmonic series. So we need to employ the alternating series test, AST. So let's start with the divergence test. So we're going to take the limit as n goes to infinity of a sub n. A sub n is everything except the negative 1 to the n power. So we're just focused on 1 over n. And that goes to 0. So it passes the divergence test. This tells us that it may converge or it may diverge. Now for the alternating series test, the second thing we need to show is that a sub n plus 1 is less than or equal to a sub n. So in this case, for the alternating series test, a sub n is 1 over n. So just keep that in mind. You take out the negative 1 to the n power. Now a sub n plus 1, that's 1 over n plus 1. 1 over n is always greater than 1 over n plus 1. So the two conditions of the alternating series test has been met. So we could say that the series converges by the alternating series test. So we could say that x is equal to or greater than 2. So 2 is included. Now we need to see if 4 is going to be included in the interval of convergence. Now let's substitute x with 4. So we're going to get the series 4 minus 3 to the n, which is 1 to the n, and 1 to the n is just 1, so we're going to have 1 over n. So this is the divergent harmonic series. And based on a p-series test, you can see that p is equal to 1. So if p is equal to 1, it's going to diverge. In order for the p-series to converge, p has to be greater than 1. Then it will converge. If it's less than or equal to 1, it diverges. So since p is exactly 1, this particular series diverges. So 4 is not included. So we can write the interval of convergence like this. So it's going to be a bracket at 2 and a parentheses at 4. So plotting it on a number line, we have the center at C, and the endpoints are 2 and 4. So we're going to have a closed circle at 2 and an open circle at 4. And here is our C value. The power series is centered at 3. And so this is the radius of convergence, which is 1. And so that's it for this problem. So anywhere between 2 and 4, if you plug it in, the series will converge. It doesn't converge at 4, but it converges at 2 and anywhere between 2 and up to 4, but not including 4. So let's work on one more example problem. Consider the power series from 1 to infinity of negative 1 raised to the n plus 1 times x minus 4 raised to the n divided by n times 9 raised to the n. So go ahead and determine the radius and the interval of convergence for this power series. So let's start with the ratio test. U sub n plus 1. That's going to be negative 1 to the n plus 1 plus 1. So everywhere you see an n, replace it with n plus 1. And then it's going to be divided by u sub n, the original expression. Negative 1 to the n plus 1. I'm going to separate it like this. Negative 1 to the n plus 1. Well, this is n plus 2 really. But I'm going to separate it as negative 1 to the n plus 1 times negative 1 to the first power. And then x minus 4 to the n plus 1. I'm going to write that as x minus 4 to the n times x minus 4 to the first power. N plus 1, I can't really change that. I'm just going to leave it the way it is. 9 to the n plus 1, I could write that as 9 to the n times 9 to the 1. Then change division to multiplication, and then flip the second fraction. Okay, so now let's simplify what we have. These two we can cancel. We can cancel x minus 4 to the n and also 9 to the n power. Now let's write these two together. So this is the limit as n goes to infinity, n over n plus 1, and then we have absolute value, negative 1 times x minus 4. Now, as n goes to infinity, oh, let's not forget about the 9 on the bottom. So let's put this over 9. As n goes to infinity, what happens to n over n plus 1? This becomes 1. 1,000 over 1,001, that's about 1. And then the absolute value of negative 1 over 9, we can take that out of the absolute value expression and write it as 1 over 9. So what we have now is 1 over 9 times the absolute value of x minus 4. And this is going to converge when the ratio test is less than 1. So now what we need to do is multiply both sides by 9. And so these will cancel. And so now we have x minus 4 is less than 9. So notice that this is the form x minus c is less than r. So therefore, we could see that r is 9. That's the radius of convergence. We could also see that c, the series, is centered at 4. So c is 4. So now let's determine the interval of convergence. So we could say that x minus 4 is less than 9, but greater than negative 9. Now let's add 4 to both sides. 9 plus 4 is 13. Negative 9 plus 4 is negative 5. So this is what we now have. Now let's rewrite the original series, which is negative 1 to the n plus 1 times x minus 4 to the n divided by n times 9 to the n. So just by looking at it, you could see that the power series is centered at c equals 4 because of the x minus 4 in it. Now, let's check the endpoints. So if we plug in negative 5, will it converge or diverge? So let's replace x with negative 5. So we're going to get the series negative 5 minus 4, that's negative 9 to the n. So we're going to have negative 1 to the n plus 1, and then negative 9 raised to the n over n times 9 to the n. Now, negative 9 to the n divided by 9 to the n, we can write that as negative 9 over 9 to the n, which becomes negative 1 to the n. And so if we multiply negative 1 to the n with negative 1 to the n plus 1, then that becomes negative 1 to the 2n plus 1. So this gives us the series negative 1 to the 2n plus 1 divided by n. So what can we do with negative 1 to the 2n plus 1? So when n is 1, 2 times 1 plus 1, that's going to be 3. And negative 1 to the third power, that's negative 1. So we're going to have negative 1 over 1. Now the next term, when n is 2, 2 times 2 plus 1 is 5. Negative 1 to the fifth power is still negative 1. And then when n is 3, 2 times 3 plus 1 is 7. Negative 1 to the 7 is still negative 1. So as you can see, we don't have alternating signs. So we can reduce the series to this. We could say that it's simply negative 1 to the n. And we can move the negative to the front. So this becomes negative, and then we have the divergent harmonic series. So according to the P series, P is 1. And because P is 1, we can say that the series is divergent. So negative 5 is not included. So we're going to have a parentheses at negative 5. So the interval of convergence is negative 5 to 13. Now let's check the endpoint for 13. So when x is 13, what's going to happen? So this is going to be 13 minus 4, which is 9. So we're going to have negative 1 to the n plus 1 times 9 to the n over n times 9 to the n. So these will simply cancel. And now we have the alternating harmonic series. So we need to perform the alternating series test. So let's start with the divergence test. So the limit as n goes to infinity for a sub n, which is 1 over n, that's going to go to 0. Remember to ignore this. So it passes the divergence test. At this point, the series may converge or it may diverge. If it doesn't equal 0, then it diverges. Now we need to show that a sub n plus 1 is less than or equal to a sub n. So a sub n is 1 over n, and a sub n plus 1 is 1 over n plus 1. So that's true. So by the alternating series test, we say that the series converges, which means that 13 is included. So the interval of convergence includes 13. So we're going to use a bracket for that. Now let's plot the solution on a number line. So it's going to start from negative 5, and it's going to end at 13. And it's centered at 4. So 4 is right in the middle. So we're going to have an open circle at negative 5 and a closed circle at 13. So this is the interval of convergence. Whenever x is between negative 5 and 13, the power series will converge. And so in the middle we have our c value. It's centered at x equals 4. And the radius of convergence is 9. So 13 minus 4 is 9. And 4 minus negative 5, that's also 9. And so that's it for this video. Hopefully it gave you a good understanding of power series and how to find the interval of convergence and the radius of convergence. Thanks for watching.